Okay, so for section 3.2, we are going to learn the chain rule and the general power rule. So this is when you have like composition of functions, basically. So if y equals f of u and u equals g of x, that is probably this. Let me rewrite this. This would be that y equals f of g of x. This is the composition of two functions. Then the derivative is going to be take the derivative of the outside function, leave the inside alone, and then multiply by the derivative of the inside. This will make more sense hopefully when we're doing stuff. This is a lot of letters, but you, if you were looking at like this as y equals f of u, then y prime is going to be f prime of u times u prime. So ignore the fact that there's a function sitting inside, do the derivative of the outside, and then take the derivative of the inside function, multiply. So the first three, we're going to basically develop the general power rule. So this is something to a power, but it's a function to a power now instead of just like it's a polynomial to a power. So what we're going to do here is, I'm trying to write this without letters, but this is the inside function u, or g of x is 2x minus 5, and then f of g of x here is 2x minus 5 to the fourth. So f of u is u to the fourth. So you would do, for the derivative, you would do f prime of u times u prime. So f prime of u, if you're looking at this, the derivative would be 4u cubed times u prime, this is u. The derivative of that is just 2. And then plug in what u was. So this would be 4 times 2x minus 5 cubed times 2. So you have here, do the derivative of the outside function. So drop this 4 down, times it, and then reduce this by 1. So that gives you the 3. And then times the derivative here of the inside at that point, which would be 2x, or just 2. Okay, so I'm going to, on this next one, I'm going to write less words and see if that makes it better. It might make it worse. I don't know. G prime of x, I'm going to take the derivative of the outside. So exponent down front, decrease it by 1. Leave the inside alone, and then multiply by the derivative of the inside. So this would be the derivative of the inside function. The inside function here is x squared plus 4. So the derivative of that would just be 2x. So I did this, g prime of x equals derivative of the outside, leave the inside alone, and then times the derivative of what's inside. Or if you want to look at this with the u here is x squared plus 4. G of u is u to the negative 2. So g prime of x would be g prime of u times u prime. G prime of u would be negative 2u to the negative 3, exponent down front, decrease it by 1, and then times the derivative of u, which would just be 2x, and then plug in u. So negative 2 times x squared plus 4 to the negative 3 times 2. Okay, number 3, I'm going to rewrite this one. So I have a power on the outside. So 4x squared plus 1 to the 1/3 power, that's a cube root. So y prime, we're going to do exponent down front, leave the inside alone. So, and then decrease the exponent by 1. And then times the derivative of what's inside. So that would be, the derivative of this would be 8x plus 0. Again, I left the inside alone here. So this would be 1/3 4x squared plus 1 to the negative 2/3 times 8x. Or you can look at this with the u's. This would be f of u is u to the 1/3. U is 4x squared plus 1. So f prime of u, or y prime, sorry, y, this is y. So then y prime would be f prime of u times u prime, and you would get this 1/3 u to the negative 2/3 times 8x. We put this in different color. So I don't, putting all the letters with it to me makes it more confusing, which is why I just do the like derivative of the outside, leave the inside alone, and then multiply by the derivative of the inside. I will tell myself that, say that to myself every time I do it, but I don't like write the u stuff every time. But what we just developed with those 3 things is called the general power rule. It's basically when you're using the chain rule, where the outside function is a power. So this is the same format we've had for those 3 questions. So y equals g of x to the n. Then the derivative with respect to x is going to be exponent down front, decrease it by 1. So I want to write this. I want you to see the outside function. So yeah, I'll do this. So exponent down front, decrease it by 1 times the derivative of what's inside. Or take the derivative of the outside, so exponent down front, decrease it by 1, leave the inside alone, and then take the derivative of the inside and multiply. So we just did 3 examples of that, the general power rule. Now we're going to look at combining the chain rule with other rules. So let's see. We have on this first one, we have, you can see that this is a product, but you also see that one of the pieces of that product is going to be the general power rule or the chain rule. It's a thing raised to power. So this is f prime of t. We would call, let's see, let me write this maybe more clearly. This would be u. Maybe we shouldn't use that. Yeah, I'm going to call this one u and v. So f prime of t is going to be first time, this is a product rule. So this is product and chain. So first function times the derivative of the second plus the second times the derivative of the first. So u here is t, v is 4 minus 3t squared squared. So u prime is 1. V prime, this is where the chain rule would come in, is going to be exponent down front, decrease it by 1, leave the inside alone, times the derivative of the inside, so times negative 6t. Let me scoot that over. So you do exponent down front, this fits this pattern, right? In down front, decrease it by 1. So put the 2 down front, decrease it by 1, leave the inside alone. And then multiply by the derivative of the inside. The derivative of 4 is 0. The derivative of negative 3t squared is negative 6t. And then you're just going to plug those things in. So we need u first, which is just t, and then v prime. U is just t, v prime is this whole thing. So 2 times 4 minus 3t squared times negative 6t. Yep. And then plus v, which is up at the top right there. So 4 minus 3t squared times u prime, which is just 1. Okay. Obviously, you could simplify, but you do not need to. Alrighty, let's keep going. On this one, we're looking at this top is going to involve a chain, but it's just going to be a quotient rule and a chain rule. Okay, so for the quotient, h prime of x, this would be, let's call this one f and this one g. It's low d high, so g times f prime minus high d low over g of x times g of x, or low low. D high minus high low over low. Okay. So f of x is the square root of 5x minus 2. I'm going to write that as 5x minus 2 to the 1/2. G of x is x cubed. F prime of x is 1/2 5x minus 2 to the negative 1/2. This is a chain rule here, because the general chain rule, or general power rule, exponent down front, decrease it by 1, leave the inside alone, and then times the derivative of what's inside, so times 5. And g prime of x is 3x squared. Okay, so our quotient here is g, which is x cubed, times f prime, which is going to be, I'm going to simplify that to just be 5/2, this 5 over, and times 1. So 5/2 times 5x minus 2 to the negative 1/2. So that is g times f prime minus f, which is 5x minus 2 to the 1/2, times g prime, which is 3x squared, over g of x squared, so x cubed times x cubed. Okay. You could, if you really wanted to, it's all in orange, baby. If you wanted to, you could have done this as a product rule. If you rewrote this as h of x equals the square root of 5x minus 2 times x to the negative 3, you could use a product and a chain rule, if that is something you prefer. Okay. This is kind of fun. On number 3, we're looking at a chain rule and a quotient rule again, but in a different way. So this is like y. How do we do this? F of u, is that how we did the chain rule? So y equals f of u. So f of u is u cubed, and u is 2t plus 5 over t plus 1. So f prime of u is 3u squared. U prime is going to involve a quotient rule. So bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared. quotient rule is low d high minus high d low over low low. Oh, I think I just meant, I don't know what that extra parenthesis is there. Okay. So y prime is going to be f prime of u times u prime, or derivative of the outside, leave the inside alone, times the derivative of what's inside. So this is going to be 3 times u squared. U is 2t plus 5 over t plus 1 times u prime, which is that whole quotient rule. T plus 1 times 2 minus 2t plus 5 times 1 over t plus 1 squared. Okay. Let me see, is there something I can do to make that? I told you I don't use all these letters when I do it, and I don't, but I did that every time for you. So let me do this again without all of that. I would do y prime equals 3 times the inside squared. So exponent down front, leave the inside alone. And then times the derivative of the inside, and then I would do the quotient rule. So HODI high minus HIDI ho. Or ho ho. Okay. Let me see. I might move. I'll do these. I may not do them in as much detail, but I will do them anyway. Y prime me here. We're going to do exponent down front, decrease it by 1. So the derivative of the outside, leave the inside alone, times the derivative of what's inside. So exponent down front, decrease it by 1, leave the inside alone, times the derivative of what's inside. The derivative of 7x plus 2 is just 7. Next up, we have another general power rule. So exponent down front, decrease it by 1, leave this part alone, times the derivative of what's inside, so times a -4. And then another one, y prime, exponent down front, decrease it by 1, leave the inside alone, times the derivative of what's inside, so times the 3x squared. On number 4, I'm going to rewrite this as 5 times x cubed plus 4 to the -1/2, and then I'm going to do the same thing I just did. So g prime of x would become exponent down front, decrease it by 1, that would become -3/2. -1/2 minus 1 is -3/2, times the derivative of what's inside, that is 3x squared. The inside I left alone as x cubed plus 4. You could do this as a quotient rule as well. The derivative of the top is 0, so half of your quotient will go away. Okay. Number 5 is the same idea. Y prime is going to be 3 times the inside, so exponent down front, decrease it by 1, times the derivative of what's inside. This becomes 8x plus 9, 4x squared plus 9x minus 3. All right, number 6 is where things get messier, and we've got lots of things going on. We have, this is going to be quotient and chain rule. Product and chain rule. So we see this product. We also see that this thing is a function to a power. So this is a product and a chain rule. So y prime is going to be first I'm going to call this u and v. So u times v prime, first times the derivative of the second plus the second times the derivative of the first. And if I go over here and do these so that I'm just not doing this in the middle of that, it's be easier. U is 4x plus 3. V is x squared plus 3 to the 1/2. U prime is 4. V prime is going to be a chain rule here, similar to those 5 we just did. So exponent down front, decrease it by 1, leave the inside alone, and then times the derivative of the inside. And then plug that stuff in. So u is 4x plus 3. V prime is that whole big mess. The 1/2 and the 2 are going to cancel, but you don't need to simplify. You know what? Okay. X squared plus 3 to the negative 1/2 times 2x. So u times v prime plus v x squared plus 3 to the 1/2 times u prime, which is just 4. All right. And then given that, so this is similar to what we did in 3.1, you're just going to sort of write down what the derivative would be for this and then plug in a 2 at the end. So h prime of x, if it's this thing, would be 4 times f of x cubed. So exponent down front, decrease it by 1 times the derivative of what's inside. So this, it would look like this. And if you were trying to do h prime of 2, you would plug in 2 everywhere you have an x. So this f of 2 is 3, and then f prime of 2 is negative 1. So 3 cubed is 27 times 4 is something. How's the negative 1? Negative 108. Okay, and then again, finding the equation for a tangent line at x equals 8, we're going to do y minus y1 equals m times x minus x1. M will be the derivative at x equals 8, or x equals whatever. In this case, we're looking at 8. So x1 is 8. We need to figure out what y1 is. So we're going to plug in 8 here, f of 8, and square root of 81, which is 9. Okay, so that's our ordered pair. So we know y1 and x1. We need to figure out the slope of a tangent line at x equals 8. So we're going to do the derivative. So f of x, I'm going to rewrite this as 10x plus 1 to the 1/2. F prime of x is going to be 1/2 10x plus 1 to the negative 1/2. Exponent down front, decreased by 1 times the derivative of what's inside. So leave the inside function alone, take the derivative of the outside, and then multiply by the derivative of the inside function. And then we want to know f prime at 8. So when you plug that in a calculator, I have 5/9. Hopefully that is right. And so that's our m. We're going to come over here and use this and this and this. So y minus y1, which is 9, equals m, that's 5/9, times x minus x1, which is 8. And there is the equation for the tangent line at x equals 8. So tangent line, you need to know the slope. If you're looking for the equation for the tangent, so the slope of the tangent line is the derivative. The equation for the tangent line, use the ordered pair at that x value in point slope form and go from there. Okay, so t years from now, the population of Castle City will be P of t equals this function. What will the population be in 5 years? So we just want to know on that one, there's no derivative, nothing happening there, just what will the population be 5 years from now. So you're going to do P of 5. So there should be 5. Okay. So once you do that and plug that into a calculator, Desmos, you get 17,000. So that should be the population of Castle City in 5 years. This rate of change thing on part B, this tells us to take a derivative. So we're going to find what P prime of T is. And why this is in this section is that this is going to require a chain rule. So the derivative, the 10 is going to hang out, exponent down front, decrease it by 1 times the derivative of what's inside. So leaving the inside alone. So the derivative of this, you're going to do exponent down front, decrease it by 1, and then times the derivative of what's inside. So times 2. And then we have also tacked onto this minus 1600t. So we're going to include a minus 1600. That's t to the first. And so the derivative would just be 1600. If we simplify this, it's 2040 times 40 plus 2t minus 1600. And then we want to know what the rate of change is. So P prime is the rate of change of the population at any year t. So you want to do P prime of 7. Plug 7 in here. And you get 560 people per year. So it's growing at a rate of 560 people per year in the 7th year. If that was negative, then the population would be decreasing each year. So at 7 years, it's increasing at a rate of 560 people per year. Okay, so that is the chain rule. Please email me if you have any questions or if you would like any more detail on this. I know I was rushing up the end. My headphone batteries are dying and it keeps alerting me of that. So I was trying to beat that from happening. But y'all email me if you have any questions. Thank you so much.